Let us talk about linked list. This is, as you know, linked list. It's a data structure which you can actually connect through, node. We call it node. For example, you can see that we have three nodes here. Node A, B, and C. Each node you have a pointer and a data node, and you can connect your data to the pointers, and ultimately pointer you are allocating a memory. So advantage of linked list is you can see that it cannot be made, it can be made as long as you require, and it doesn't waste memory. Why? Because if you need to store only, then you allocate memory, otherwise not. So look at this, keeping track of linked list. One thing is very important, that we must know the pointer to the first element of the list, called start, head, whatever you call it. Why? Because it is in the memory and we do not have any absolute location. It is dynamically created. So linked list provide flexibility, how we can insert an element, we can delete an element. Look at the insertion. What we do in the insertion, we have three nodes here, A, B, and C. They are connected. And if you see an item X, we want to insert between A and B. So what we do, we actually reassign the pointer of A pointing to X, and X has a pointer that is pointing to B. So we are actually relocating the pointer, and by relocating the pointer, we are inserting an element. Deletion, in the same way, what happens if three nodes are connected and I want to delete B, items to be deleted? What we do is just reorient the pointer of A. That means I'm going to connect the pointer of A to pointer of A to C. Automatically B is disconnected, and we can free this memory. In essence, insertion, a record is created holding the new item. The next pointer to the new record is set to the link of the item. The next pointer of the item which is preset, it must be modified. For deletion, in the same way, the next pointer of the item which is about to be deleted is altered. That means we are reconnecting the pointers for insertion and deletion. Array and linked list. As you know, arrays are suitable for inserting, deleting element at the end, randomly accessing element, because you can just insert, you can actually consider an index, and by considering an index you can actually access any array elements. But linked list, very suitable for inserting and deleting, and you don't have any wastage of memory. Applications or sequential access is required because you don't have any index here, and the number of elements cannot be predicted beforehand. In situation, it is difficult because in linked list we only know it is a dynamic allocation. Those talking about the types of linked list, depending on the way in which the linked list are assigned, we can have a simple linear linked list. We call it linear list, or simply linear list, where we have three nodes are connected to each other and we have a head pointer. Circular linked list, as you see what happens in the circular linked list, you have three nodes, they are connected to each other, but the last node, the pointer is pointing to the first element. That means the pointer from the last element in the list points back to the first element. If it happens, we call it circular linked list. So circular linked list creation is very straightforward. What you do on the last element, you put back into the first. That means if I say X, if it is my node, if it is a node C, then node C next is actually node A. It's very straightforward. Circular linked list. Talking about doubly linked list, doubly linked list pointer exists between adjacent node. For example, each node has two pointers. One is a previous pointer, another is a next pointer. So the list can be traversed either forward or backward, because you can actually point. It's very interesting. I will show you in a code that how we manage doubly linked list. And the list can be traversed, and usually two pointers are maintained, because you have to keep track of head and tail, because you have two end, head end and tail end, and in each end you have actually pointers pointing to a forward and reverse. That means if I say A next previous, A next is equal to B previous, the previous pointer, like this. So basic operation on the list, we create a list, we traversing a list, we insert an element in the list, we delete an element from the list, and concat two lists into one. So these are actually basic operations, and practically what happens is this. Up to here we can see that there are abstract data types. I just want to show you some of the conceptual ideas, insert, delete, and list implementations. You can see an example here. This example, I'm showing a node of a student, struct student. Generally, I have roll number, name is a character, age, and the pointer. This is actually a self-referential structure, you can understand. And then I create my node type, create a head. So the first thing, I define a node and create a data type. So the data type node actually is of type struct student. And now I create a list. What I do in creation of list, you see, to start the creation of list, I have to allocate memory to the node. So head is equal to node pointer malloc size of node. So as a result, how it looks like, this is a very important that you know how to draw this picture. Head is pointing to a location where you have 3 data members and the next pointer. So once you have it, then you actually have n number of nodes created like this. You read one by one and create. So what I show you here is this, that I have a create list returning a pointer, and then I actually do one thing. Here I read all those items and create a node. You see, I'm scanning, I'm reading 3 things: role, name, and age. And actually what I'm doing in the loop, when you come inside, you declare 2 variables, then 2 node, head and p. It's a temporary pointer. You're asking from the user how many students to enter. You read in n. Then you loop n times. If k0 means you're talking about the first node. So you need to create a first node. P is pointing to the head. Fine. If k is not 0, that means you are actually allocating the next one, p next, and then move the pointer p to the next, because you have to read in p. So what you do, you read in p, this through pointer, using pointer, you're reading roll number, %d, space %s, you're reading name, and then again a space, there is a space for age, so ampersand age, and then finally the loop is complete, means the reading and storage is done, and the next pointer you must assign null, and then actually you have already assigned, actually you can understand, you're returning the head. Why? Because actually head is getting allocated, and head is actually pointing to already p. You see, head is equal to p in the if block. Alright, so once you have the list, then actually you called in the main, you declare a pointer variable and create list. Head is now pointing to the list, and you traverse to the list. What is to be done? You actually travel using head and display different content and pointing to the next. See, look at the display function. I'm passing the list here. Count is equal to 1. That's temporary node. I assign this p to head because I don't want to move the head here. So p not is equal to null, then as display the role, name, and age, and p next. You move next, display all student, roll number, name, and age. And then finally you can call from the main like this, display head. Now inserting a node in the list, what to do? The problem is to insert a node before a specified node. You must say where to insert, and the convention is if the value of role is given a negative, the node will be inserted at the end of the list. So when a node is added at the beginning, and the node is created and the node is deleted, and practically taking a look at it, this is the insert. Why we are putting double pointer? Because we are sending the reference of the head. Otherwise we are actually doing every operation in the list. So we have actually 3 temporary pointer, p, q, and new. New is my new node which is going to be inserted. So I read the data from the user and then assign that this new is actually not a new is holding actually a new node. Okay, new node. And then you see insert before role, -v means stop, Then I assign this, reference of the pointer. P is equal to, P is a pointer, you can understand, and you're passing actually a double pointer. That means reference of a pointer. So you store the pointer in the P, and if P is not equal to roll, then next, otherwise head next at the beginning. And then else what you do, if it is not null, you have to actually find a location to, you're checking the roll number where you are going to insert. If P is null, then it is at the end. Otherwise, you insert in between. So, how do you call? Insert and then pass the reference of the head. As I am saying, head is a pointer. You're passing the reference of the pointer. Deleting a node also same goes. You can actually delete, mention a roll number, which one you like to delete. You may delete the first one, the last one, or the intermediate node. In this case, delete function, you are asking, in the delete function, you are asking which roll to delete, and you scan the roll number, and you're looking for that roll number to delete. If it happens, next, and then free the P. Otherwise, what you do, you look for, the node, the roll number, where you're going to locate it, and find that location. And finally, if it is null, that means there is no match, there is no such roll number, you cannot delete. Otherwise, you delete. Okay. So these are actually free to exercise, but what I want to tell you is that this is a very important operation indeed, and enjoy the linked list. Linked list is the foundation.